think basically I will do during this Bibliographic an introduction to hardware acceleration. I'm Cyril Vlaminck. I'm I'm a passionate Android developer. I work as software engineer at Buddies. Here is the link to the presentation and the GitHub for the demo that will not happen. Sorry, it's technical problem during the preparation. So let's start. Just a question, who is using hardware acceleration here in this room? One. I'm not sure that's totally true. Hardware acceleration is something that has been added in Android with Honeycomb at API level 11, and it's enabled by default when your application is targeting API level 14. So who is targeting API level 14 in this application? Yeah, you are using hardware acceleration. So what is hardware acceleration? It's a new drawing model made to accelerate drawing of view and drawable. The bases are to accelerate animation. First, I will talk a bit about the traditional model that were available in Android 2.x version and are still available today. So, in this whole time, the rendering was done by the CPU. I mean, you were having a kind of a bitmap in the framework where every operation were rendered. You draw a line, that's the CPU drawing some pixels on a bitmap. It's explained a bit why animation on 2.x were a bit slow. The drawing on Android is a kind of a two-phase process with the invalidation and the drawing. Who understand a bit what is invalidation? Okay, just for everyone here, invalidation. When you do an update, for example, I have quite a simple layout. I have a linear layout and a text view. And what occurs if I want to change the text view, the content of the text view? Well, when I do the set text on the text view, Android will mark this view as dirty with the invalidation. So this view will need to be redrawn. Question, is it enough to just redraw this view? Well, no. Since it's a software process, you need to draw the background, or otherwise you will end up with something like that. We have the two texts drawn one over the other. So yeah, you need also to invalidate the parent, invalidate the view. The parent will be redrawn, the view will be redrawn. That's basically the invalidation process. That's still valid today, even with hardware acceleration. So, hardware acceleration, it's a new drawing process which replaces the old one, and where operations are done by the GPU. The way Canvas works has totally changed. Instead of making the CPU draw on a bitmap, it will cause operation to be listed in an OpenGL display list. Display lists are very, very simple. It's for example, if we want to make a display list of this view, each view has its own display. So to draw a linear layout containing a list view and a button, you just have a display list that draws over display list. Well, okay. So just draw the list view, draw the button, and each do this list contains draw a line, do a transformation on X and Y. So it's a list of operations that will be rendered later by the GPU. One thing to understand is that the OpenGL call are still made synchronously. So when you're calling the draw line on the canvas, it will issue an OpenGL call that will be stored in the display list. So you can still have a performance problem on draw when you are building those display lists. So yeah, the pipeline for the for the hardware accelerated model, you have still invalidation to mark the view that needs to be updated, but instead of a redraw, we will have an update of the display list. So each view invalidated will record our display list, and then later Android will will ask the CPU to draw all the display list. So yeah. Another question is there's some properties that are known to be better for hardware acceleration, such as alpha. But what happens when you change the alpha on the list view in the previous layout? In the traditional model, you invalidate the list view, you invalidate the linear layout, you redraw everything. Basically, set alpha will cause your layout to be fully redrawn. That's not very good. Hardware acceleration change lots of things on this point. Instead of just redrawing everything, it will do some optimization. So just we will take a look at the display list with the alpha. What has changed? So, well, the display list of the list view hasn't changed at all. When you change the alpha on hardware acceleration, the draw method of your list view is not called. So if you have heavy operation on your on draw, they are not called. So it's very good for animation. So just updating so what it will cause, it will invalidate the linear layout, only the parent. It will cause the linear layout draw to be called, to update, to add the save layer alpha and the restore, and it will be drawn. So very, very light to change alpha on hardware acceleration compared to the traditional model. So what are those operations that are quite friendly with hardware acceleration? All the things you can animate with the property animator in Android. So if you do animation, use this property, and do not try to animate the layout params or some other things. So we can think that hardware acceleration is quite nice. We have a better performance, beautiful animation, and yeah, it's quite cool. I mean, yeah, I want to use it. Yeah, but there's some trouble. Not everything is supported by hardware acceleration. One great thing is that if you are using only views that are in the frameworks or in the support library, Google has done all the work for you to make them compliant with hardware acceleration. So it's good. You just you just don't care. Your app is hardware accelerated by default. since you are targeting API level 13, and that's all. For those who are doing a custom view, like I love to do, well, it can be a bit messy. More and more operations on your canvas are added to hardware acceleration, which cause your code to be API specific. You have to have a drawing logic for full hardware acceleration, a drawing logic if you miss some operation, and that's quite a lot of work. I've just listed some operation and the API level, and some operations that are not used. Just a thing is that the most basic, the basis operation on Canvas are supported. So if you can be you can be lucky and just have hardware acceleration without worrying at all. Yeah, just for information, what happens if you call an unsupported operation on your canvas? Well, the operation doesn't work, so it will do nothing. For example, if you draw rounded direct, the rounded direct will not be drawn. It's we will have a graphic artifact. So yeah, it can be useful to disable hardware acceleration if you are using some of those operations for your custom view. So here we have 3+1 method, because basically you can disable hardware acceleration for all your application in your manifest. Just precise hardware accelerated false in your application tag. You can also disable it on a specific application. Same thing, hardware accelerated false on the activity tag, and you can do it on the window. The first two calls, the first two methods disable also the hardware acceleration on the window. So it's the same thing, just two that can be done in the manifest and one by the code. The last one, to disable hardware acceleration on a view, it's quite tricky, as LayerType are not only to disable hardware acceleration, they are doing other things that can hurt your performance. You need to know a bit about LayerType before trying to disable hardware acceleration using this method. So, as I said, we can disable hardware acceleration, but we also can test for it. Two methods to test. You can test on your view. So it will return true if your window is hardware accelerated. So if you have set it hardware acceleration through on the application tag, on the activity tag, or straight on the window, yeah, you will have a true. And you have hardware acceleration you can check for hardware acceleration on your canvas. That's what you need to do if you have a drawing code that is specific for hardware acceleration and non-hardware acceleration. And you have quite weird case where you can have view is hardware accelerated that returns true, and the canvas that is hardware accelerated that returns false. So when you are drawing, you test on the canvas. When you are if you want, for example, to disable an animation on a view, if you don't have hardware acceleration, you test it on the view. So yeah, it should be the time for a demo where I will show how to adapt to this limitation of the hardware acceleration, or if you have a custom view, how to deal with an operation that is not supported. but I have a little issue on my computer. It was working fine this morning. The demo doesn't want to launch now, so I will keep speaking on the layer type instead. So as I said, there is something between on this slide is the view.set layer type. I mean, we are developers. What should we do if we want to disable hardware acceleration on something? It's a set hardware accelerated property, but it's not the case if, meaning it's something different than disabling hardware acceleration. What is a layer type? So it was introduced at the same time as hardware acceleration, and basically is a drawing cache. Your view will be drawn on a cache of some kinds, depending on the layer type, and will be rendered later. So there's also some specific things, like you can do a black and white view using a layer type, using a composition matrix. So, as I said, it's something more than disabling hardware acceleration. There's two types of layer, software and hardware. Just so how you set them? Yeah, it's just quite simple. View.set layer type, or you can set it also on your layout in your XML. You can change layer type dynamically, just before an animation, at the end of an animation, which is not the case for the hardware acceleration. I mean, when you have hardware accelerated a window, you will do it at the start when no view is attached. But for the layer type, you can change when you want. Do not do it, as I said, it's a drawing cache. So if you change from software to hardware, it will destroy the software drawing cache and create an hardware one. So it can cause performance issue if you change too often, or when you don't need it. So be careful. So the layer type software. The view cache will be simply a bitmap. Really, the bitmap you can find in the Android API. So instead of drawing on the display list, as I've explained you before, you will have a bitmap where your view will be drawn. See, it's the case where you can have a view that is hardware accelerated, since the window is hardware accelerated, but the canvas, as it is a bitmap, is not hardware accelerated. So, yeah, when you are drawing, really check canvas is hardware accelerated. Yeah, one thing is it's as it is a bitmap that is uploaded then to your GPU to be rendered. Invalidation can be quite costly. When you change something on this layer, it will cause your bitmap to be redrawn. Then, as the bitmap has been redrawn, it should be uploaded on the GPU to be rendered in the display list. So, yeah, you do quite costly operation. If you can avoid using the layer type software, it's quite better for your application performance. So if you really need drawing cache, as they are really performant, you should try to keep this one, LayerType add. What it will do is, instead of building the display list, everything will be rendered on a texture that will be ready. So if you want to animate a view that has quite consuming on draw method, you should use a LayerType hardware just before the animation. So before you start your animation, you set LayerType LayerType hardware. You do your animation, and then at the end of your animation, you go back to your LayerType none to save the GPU memory as you will create an OpenGL texture that consumes your RAM. So more information on what you can read, check to know how it is working. First thing is the hardware acceleration guide. It's really good, a bit dense, really dense, but it contains most of the information I have given you here, and then you have the different platform library that are in charge of the hardware drawing or the software drawing. Thank you.
Any question, maybe?
Hello. Excuse me because I missed the first part of your talk, but maybe you told about it. Could you tell us about some sample use cases where you used the hardware acceleration in an app in your job?
The first thing is that even if you didn't notice, hardware acceleration is already enabled in your application. One thing that really needs hardware acceleration is a web view with JavaScript animation. You can have, if you're trying to do a rounded web view, you can have this kind of thing where you use a the clip path operation to have a rounded web view, and you need to trick a bit with the hardware acceleration, as clip path is only supported in hardware acceleration since API 18, if I remember correctly. So,
thank you.
Hello. Is there any performance issue switching between hardware and software layer at runtime?
Software layer are a bitmap. You will draw on a bitmap using the traditional model, so it's the standard canvas operation. So one thing is on hardware accelerated application, you should not do that, as you will draw on your bitmap, then the bitmap will be copied in the OpenGL memory as a format, as a texture, and then rendered. So every time you change your layer, you do the re-upload, and it's not great for performance at all. So if you can afford using LayerType hardware, if you don't have the operation I mentioned earlier, it's better to do with hardware only.
Okay, last question.
So I saw in the slide that the anti-aliasing was not supported in the early version. So how you deal with that? That could be a bit not very nice, not having this.
in this case, you have to go back to non-hardware accelerated canvas. So you may disable some of your animation to have a better, not preference, but user experience. But yeah, it can be quite tricky. One thing you can do if your view are small is doing one LayerType software. If the view is quite small and does not change, it will do the rendering of the anti-alias with the software. So it can be done, or you can have your own during cache logic if you need something more specific.
Okay, thank you very much, Cyril. Yeah, we can applaud.